Alright, now we're going to do
Using simple methods of factoring. Do you like my hat?
we use several methods of factoring. We want to factor polynomials completely. So we make like kind of like an order of operations to how the order we're going to do these things. We're going to first do our monomial factors, then our difference of squares, check for difference of squares, then perfect square trinomials, then binomial factors, that's the sum product, we see if there's some product, you know what I mean. Then we check grouping when there's 4 or more terms. And then you check all the factors again to make sure they can't go any, and then you check your answer by multiplying your factors and make sure they work. Alright? So, a little mnemonic device to remember this is, what I like to say is, my dog plays banjo great. Check, check. Yes, that's true. My dog plays banjo great. And actually, another student came up with another student of mine came up with an even more creative one. He said, "My dog prepares big, greasy chicken cutlets," which was actually I like that one better, but I already made this, so I'm going to keep it as "My dog plays banjo great." Check, check. So here we go. My dog plays banjo great. All right, so here we go. Sometimes you have to rearrange terms too, so beware. But first, let's check. Let's start off from the top here and say if there's any monomial factors. Write out what jumps out at me. A jumps out, so I'm going to take that A out, and there's the coefficients have nothing in common. Well, all 3 don't. These 2 do. So I'll factor the A. And it says you may have to rearrange these terms. Let's see what happens. Take the A out. 81 plus 18A squared plus A to the 4th. Alright, well, let's see. I have a perfect square here and a perfect square here, right? Isn't this square of 9? So remember, it goes, first you do monomial factors. Then, oh, you can have my dog plays banjo. Monomial factors. Difference of 2 squares, no. Let's look for perfect square trinomials. This is A squared squared. So this would be a perfect square trinomial if this guy is twice the product of the roots. 9A squared twice, yes. So I know I have a perfect square trinomial, so I have A times 9 plus A squared squared. Neat. Now what can I do here? These are the sum of 2 squares. It's not the difference of 2 squares. This would be a much different problem. If this was a negative, then this would also be a negative. And then we have a difference of 2 squares in here, and we'd have to, we'd have to go quite a bit further. We'd have to do 3 plus A times 3 minus A times 3 plus A times 3 minus A. And we'd end up having 3 plus A squared, 3 minus A squared times A. But it's a sum of 2 squares, so we're done. And we check by multiplying it out, but I don't have time in the video to do it. Sorry. Alright, now, here we go. Let's start again. Monomial factors. I notice some P. I see a P in there. I also notice there's a Q. I also notice there's a 2. 2 goes into both of these. So let's factor 2PQ out. And let's see what remains. 2PQ times 4P squared would give me the first term. 2PQ times 9Q squared gives me the second. Alright, so I check monomial factors. My dog plays B. I got the monomial factors out. Let's see if there's a difference of 2 squares. There's no more monomial factors in here. Oh, look at difference of 2 squares. This is the square of 2P. This is the square of 3Q, right? So I can rewrite this as 2PQ, 2P plus 3Q, 2P minus 3Q. Alright. All factored. Woo! All factored and ready to go. And double check any difference 2 squares, anything else to factor. Nope, multiply it back out. You notice you'll get what you started with. Alright. Now, here we go. What do we have going on here? Well, let's see. We've got a lot of stuff going on here. I notice there's some variables in common. This guy's got 2 x's, at least 1 x. What about 12, 9, and 9, so 3 goes into each of these, okay, and no, I can't get a y out of each one, so let's divide each one of these by 3x, and let's see, 3 goes into 180 60 times, so I get 60xy minus 3 goes into this, let's see, 36 times, yeah, that seems right, 36. 36y squared, whoops. And we know this is 25x squared. Alright, that's good. Now what do we have? Ooh, let's see. Y squared. Let's rearrange these terms so that I have, well, I don't like these negatives either. So I'm going to switch the sign here, and that will switch all these signs, because I see a perfect square and a perfect square, but they're both negative. Squares can't be negative. If I switch the out sign, all the inside switch. So now I have nice two squares that are positive. And I'm going to look for a perfect square trinomial in here. I got a feeling that's what's going to happen, but let's see. 25x squared minus 60xy plus 36y squared. The reason why no square can be negative is because any number times itself is always positive. Negative times negative is a positive, and positive times positive is positive. So we need to make sure these guys are positive. To be a perfect square trinomial, let's see, the square root of this is 5x. Square root of this is 6y. Let's see, the product of these guys is 30xy. That is twice the product, so I have a perfect square trinomial. But it's going to be the negative. There's going to be a negative between it. 5x minus 6y squared, negative 3x. Now I double check. Can I factor this anymore? The answer is no. Done. Alright, let's factor this guy by grouping. It's kind of wild, man. Wild. Let's see. Perfect square. Well, look at this. Do I have a perfect square trinomial? Ooh. No, because that's negative. You can't have a negative square, because it almost was. This would have been 2yx, but this wouldn't be the middle term, so it wouldn't be a perfect square trinomial. Let me do my order again. Monomial factors? No. Difference of squares? No. Perfect square trinomial? No. Wait a minute. Do I have a difference? Let's rearrange this. I might have found a difference of two squares. How about this? With a little rearranging, do I have a difference of two squares here? Ooh, I did find a little difference of two squares hiding in there. So, let's see, the root of this guy is x, root of this guy is 2y, so I'll have x minus 2y times x plus 2y. Now what can I factor here? How about a negative 2? Yeah, I take a negative 2 out, negative 2, and I get x plus 2y there. Ooh, look at these two terms. They both have x plus 2y in common, so I get that x plus 2y out. And x plus 2y times this guy makes the first term. And times negative 2 makes the second term. There we go. That was tricky von tricky. Ooh. Alright, finally we'll just do one more here. Alright, this guy's kind of wild and crazy. What are we going to do? What are we going to do? Well, I can just start by, this is x squared minus, this is a difference of two squares here. I notice these have a, let's see, if I rewrote this, just kind of doing a little trial and error here. This might not work out. You know, when you get to these, you can't factor. What we have to do is to multiply all these guys and combine like terms and stuff. But let's see how this works out. I'm going to write this as x plus 1, x minus 1. I'm going to look at this side and see if I can factor. I'm going to take a negative 6 out of there. And I get an x plus 1. Oh, notice I have a perfect. You see what you're trying to do. You want to get a term, a similar term, and these both have a similar term in it. So let's take that x plus 1 out. Nice, dude. And this term becomes x minus 2.
Hey, there's 2x.
X minus 1.
There's 2x plus 1s.
Yes, one here and one here. That's why I'm factoring it, bud. Hey, Sniffy, keep it down. Sniffy Von Sniffy's trying to join in the party, the math party. All right. So let's see here. Am I done? Well, let's do some little bit of multiplying these two binomials. Let's see if I have enough time. I have almost. I get x squared minus 3x plus 2 minus 6 becomes x squared minus 3x minus 4. Are the two numbers whose, oh yeah, how about negative 4 and positive 1? I get x minus 4, x plus 1. I factored this inside into nice times x minus 1. Don't forget your buddy right there. Alright, all factored. Kind of had to go through that quickly. I apologize, but we're running out of time. I looked inside and I noticed this was kind of messy. I want to see if I can get it down to just binomial factors or monomial factors. So I said, alright, let's multiply these two out. Got this bit right here. Combined like terms with the negative 6. Found out I had a factorable trinomial. Factored it and brought this last term down. See? How easy?